So how many people here use Firefox? Raise your hand, please. How many people here use Firebug? Raise your hand, please. Thank you, Joe Hewitt and John J. Barton. How many people here use YSlow? Oh, ouch. Okay, so YSlow is this extension that I built a year or two ago, and it's a new tab added to Firebug. You can see it says YSlow there. You can download it on developer.yahoo.com/YSlow. And what it does is what I'm going to be talking about today is how to make websites faster. And I would go around, I'm at Google now, but previously I was at Yahoo, and at both places I go around and I talk to development teams and explain what they can do to make their websites faster. And I found that there just wasn't enough time for me to go around and reach all the teams that I needed to talk to. So I codified that knowledge into this plugin called YSlow. So you can run it, and it's hung right now, and there's something about Career Builder. Oh, there we go. Awesome. I don't know if that's me or not. I won't take credit for it. And what it does is it evaluates the web page according to these rules that I'm going to talk about today. So here we'll go to Yahoo, and right now I have YSlow in auto run mode. That means as soon as the onload event fires, YSlow will execute. And so it gives you an overall weighted score for the page and then breaks it down according to the 13 rules that I had finished last year. And what I'm going to talk about today are a new set of rules that I've been working on, and we're going to talk about the first 3 of those. So I'm kind of getting ahead of myself a little bit. What I wanted to do before I jumped out of YSlow was, I put this on because to me the most awkward part about doing a talk is when you're up on stage by yourself waiting for the people to come in and for the start time. And so I started this a while ago. I just run this in looping mode. And it's always interesting to me. So what we did while we were waiting was I was running through the top 1,000 websites according to Alexa in order. And so shout out, what do people think the most popular grade they saw was? How many people think the most prevalent grade running YSlow is A? Across these, so these are the top 100 sites. I think it's US though. I don't think it's world. It's top 100 sites in the US. Okay, so it's not A. B. How many people think it's B? How many people think it's C? How many people? Okay, some C's. How many people think it's D? D. How many people think it's F? Yes, it's F. And so I'll talk about stuff. I won't talk about it today, but last year I talked a lot about things that seem kind of old hat, like caching headers and using a CDN. And a lot of times I get feedback from people who maybe are more leading edge developers talking about how this stuff is kind of old hat. And my response is, yeah, but the top 100 websites in the country aren't following these best practices. I guess another possibility is that YSlow is just wrong and it's giving these bad grades, but it's not. I mean, there are sites like the Yahoo homepage that get A's, and it could be maybe that the stuff that YSlow is measuring really aren't relevant. And I'm not going to talk about it today, but in previous talks, I've shown that I've done a study that correlates page weight, that's the total amount of bytes being downloaded for the HTML and the images and JavaScript, page weight, YSlow score, and response time. And they're all highly correlated at 0.7 or higher. 0.5 is a very high correlation. So YSlow score is highly correlated to response time. And so you really want to maximize your YSlow score, so it's a good thing to run. So anyway, let me get into the actual talk. So my name's Steve Souders. I've been at Google for about 4 months. Before that, I was at Yahoo for a while, and my latest role there was as Chief Performance Yahoo. And what I do is I look at how to make websites faster. And I try, the thing that's most exciting to me is to find best practices that can be applied not just across all the the properties or websites at Google, but across all websites worldwide. And it's amazing that there's actually quite a number of these best practices, and I'll talk about them in a minute. But one of the first things I discovered, my background in working on the web has been back-end architectures, caching architectures, databases, things like that. And so about 4 years ago at Yahoo, I started this performance group. And I said, okay, well, up till that point, when people asked me about optimizing performance, I thought about optimizing the web server performance. I can get a response off in 57 milliseconds. Can I cut that down to 50 or 40 milliseconds? But when I started this work on performance, really what our number one goal was to improve the performance from the user's perspective. And that means response time. How long does it take for the page to load? So I said, okay, well, let me look at things from a different perspective then. Let me fire up a packet sniffer and see how long it takes for pages to load. So this is a waterfall or HTTP profile for my favorite packet sniffer, IBM Page Detailer. And each of the blue bars is an HTTP request. The x-axis going left to right is time. And so what we see is and the icons I know, and they're pretty recognizable. The first one is an HTML document. The red S-looking thing is a style sheet. The scrolling thing is a script. And then you can see images. It says JPEG or GIF on it. And so what we see is that the first thing that comes down, the first HTTP request, obviously, is the HTML document. And then the browser parses that, and it builds this queue of resources that it has to download, images, scripts, style sheets. And those get downloaded according to a bunch of behaviors that are programmed into browsers. Some of those are subjective. Some of those are suggested or dictated by the HTTP spec. And so you get this overall response time that really is pretty long when you incorporate all these other resources in the page. So in this case, this is iGoogle with an empty cache. And we see that the HTML document is only 9% of the overall load time. The other 91% is what I call front end. It's not really front end because there is network traffic for this, but it's all the stuff after the HTML document. So 9%, that seems pretty low. So maybe that's because it's an empty cache. What is it with a prime cache? Even with a prime cache, the HTML document, which isn't going to be read from cache, the headers say don't cache it, is 17%, and there's 83% is still reading these cached resources off disk, parsing them if they're CSS and JavaScript, executing JavaScript, and rendering the page. So I thought, when I first saw this, I said, well, this seems kind of weird. All my life I've been optimizing back-end architectures, and it's really only 10 or 20% of this page. So I said, let me broaden this search. So here's the top 10 U.S. websites according to Alexa, and I show the amount of time for the front end for an empty cache and a prime cache. And what we see is that for all but two, Google Search and Live Search, less than 10 to 20% of the end user time for the user waiting for that page, less than 10 to 20% is spent on the HTML document. And that includes the requests going up and all the packets coming back, less than 10 to 20%. So this resulted in the performance golden rule. If you really want to work on response times, you need to remember that 80 to 90% of the time the user is waiting for a page to load is spent on this front-end stuff, and that's the place to start. There's 3 simple reasons why that makes sense. There's just an a priori greater probability of making an impact. In your wildest dreams, if you could improve the back-end response time by half, cut it in half, you might cut 5 to 10% off the total load time of the page. But if you can cut the front-end part in half, you can cut 40 to 45% off the time the user is waiting. So that's really noticeable. The changes are simpler. To cut the back-end time in half, you'd have to replicate your code in more data centers, improve your databases, optimize your code. These are things that take weeks, months, maybe even a year. But the changes that I talk about are things like change your web server configuration to add an expires header or move a script from higher in the page to lower in the page. These are things that take hours, maybe days. So the changes are simpler. They have a greater probability of having an impact, and they've been proven to work. So at Yahoo, Google, and now since YSlow has been published, I've published a book. I get feedback from companies every week. 2 or 3 companies will contact me. And it's generally the case that you can drop in on any website, apply these rules, and reduce the load time by 25 to 50%. So this isn't just at Yahoo and Google. This is at every company that I've talked to. So here are the 14 rules that the first 13 are incorporated into YSlow. I'm not going to talk about these. I did a bunch of talks last year about this. I had developed those 14 rules. I had a hard time evangelizing that because I just couldn't reach everyone, so I codified it in YSlow, and then I published this book last year, High Performance Websites, and it basically describes each of those rules. There's a chapter on each rule, and then I deconstruct the top 10 websites and look at the good and bad things that they're doing from a performance perspective. Another thing that's going on is I'm co-chairing Velocity. That's coming up next month in Burlingame, right outside San Francisco. And that's the first O'Reilly conference that's focused on performance and operations. Jesse Robbins is the co-chair. He's directing the ops track. I'm directing the performance track. We're going to have people from the IE and Firefox teams there. John J. Barton, the Firebug guy, is going to be there. The Fiddler guy, HTTP Watch guy, AOL Page Test guy. Talk about MySQL performance. It's going to be a good conference. So if you care about performance, I recommend you head there. Okay, so this is what I wanted to start on today. So I'm starting another book. I'm about 4 chapters into it. And these are the 10 rules I have identified so far. And what I want to talk about today, kind of like the first book, I did the rules in priority order. And so what I want to talk about today are the first 3 chapters that I completed, and they all focus on JavaScript. So my takeaway at the end, I'll have a couple takeaways, is my focus for this year is to really work with teams and focus on JavaScript performance. So a lot of these best practices, previously, the YSlow rules, a lot of them focus on the empty cache experience. And that's really important because the first impression that a user gets on your site is going to set the expectations for what's to come. So if that first page view, which is probably going to be an empty cache page view, is slow, that's going to set a bad impression for users. So we don't want to do that. So those first 14 rules are really important. But things like JavaScript and CSS that are in the page have to be parsed and executed on every page view. Even if they're read from cache, the JavaScript still has to be parsed and executed. And so what I'm seeing are, if you remember the iGoogle waterfall chart, it only had 2 HTTP requests. And in the middle, that, 83% was almost all reading stuff off cache, and most of it was JavaScript execution. And that JavaScript execution happens on 100% of page views. And what's important is to try to cut that down. And if you can cut that down by 20% or 30%, that's going to be a savings that you have across every page view on your site. So I want to talk about these 3 rules, and it's going to be pretty heavy. So my job is to try to keep you engaged and pull you along. I hope I can do that. Okay, so why focus on JavaScript? Let's look at these top 10 sites. Not all of them. I'll look at some of them. So when I look at a waterfall chart like this, when I want to find the things to optimize, I look for a gradual slope. When I see a very steep slope, this isn't the whole AOL thing. AOL has like 87 HTTP requests or something. I'd have to have 4 screens to show it all. But just here at the beginning, like that second 2/3, I'm not worried about optimizing that. The requests are short. There's a lot of parallelization. The curve is very steep. I want to optimize, since the x-axis is time, I want to optimize places where the curve is gradual. And so what I've circled up there are places where the curve is gradual, and guess what? That's all JavaScript. eBay, Facebook. It's pretty steep, but it's because they have a lot of requests in their page. If you actually look at the time here, this is like 4 or 5 seconds. MySpace, Wikipedia, all these things that are circled are JavaScript. Yahoo. Yahoo's interesting. You see these white gaps? This is most likely JavaScript execution, because these are all empty cache. So they must have a lot of inline scripts. There's also white gaps after the HTTP request for scripts. But when you don't see a script HTTP request and you see a white gap, that's most likely an inline script executing, and YouTube. So why is JavaScript so bad? So JavaScript blocks. So here's the normal way you might pull in a script called A. And what we see here is an HTTP profile where the first two, after the HTML document, the first two items are scripts. And each of these scripts are programmed or configured to take 2 seconds to download and 2 seconds to execute. And what we see is and then after them I've got an image, an iframe, and a style sheet. So rather than download them all in parallel, they're all on different domains, so there's no domain blocking going here. They could all be downloaded in parallel, but all major browsers, all browsers that I know of, block when they download a script. Why do they do that? Well, the script might alter the page. It might add a DOM element. It might even do document.write. So I don't want to jump ahead and render other stuff and then have this script execute and things are out of order or I have to redraw the page. That's not good to have that flash experience for users. So all browsers block when they're downloading a script. And they also block when they're executing that JavaScript. So what happens is the script gets downloaded, that takes 2 seconds. It executes, that takes 2 seconds. The next script comes down 2 seconds, and then it executes 2 seconds. And then I can download all this other stuff in parallel. So that's the problem with scripts. Oh, I wanted to talk about Kazillion. So how many people here have used Kazillion? Wow, that's more than I expected. So here, let me click on it. So Kazillion is a thing I wrote, and Google let me release it open source. So let me see. I think I'm firing up Firefox. Here we go. Bing. And let me turn this guy off. So what it does, I'll go ahead and clear this. For me, it's really valuable. When I'm trying to look at these edge case experiences and see what the effect is, I can fire up Kazillion and I can create kind of an example that exaggerates the problem, and that helps me really kind of reverse engineer how browsers work. So let me fire up IBM Page Detailer, and we'll do something like we'll create an external script, and we'll say 2 seconds to download and 2 seconds to execute. And I'll do an image, and then I'll do another external script and another image. There we go. And we're going to put this one down there. And now I'm going to create the page. So it does a couple cool things. It actually has timing in these, kind of dynamically created scripts. It has timing information. So I can actually see in the page itself when the scripts were done executing. So the first one takes 2 seconds to download and 2 seconds to execute. So it was done executing 4 seconds into the page load time. And then I started downloading an image and a script in parallel. But the script took another 2 seconds. And so that would have been, but there was no execution time. So that one stopped at 6 seconds. And now we can look at this packet sniffer, and we can actually see that's the behavior that occurred. The script downloaded, it executed, we got 2 parallel downloads, but this image was blocked because the browser won't download it until the script is done. So that's Kazillion. It's very cool. It's out there. It's stevesouders.com/Kazillion. So if you want to poke at these, so I use it to create my examples. And if you want to, if you have questions about, well, what's the behavior of style sheets in Firefox, you can use Kazillion to check it out. Oh, and I want to mention the slides will be up on my website right after the talk. So I want to dig into these 3 rules now. So the first one is split the initial payload. So what I'm talking about here is these are the top 10 sites again. We're putting more and more JavaScript into our pages. If you look at Facebook, it's over a meg now. So that's a lot of JavaScript. Now, this is the thing that I want to address. This is how many of the functions downloaded were actually executed by the onload event. So I had to do this fairly manually. It'd be great to automate this, but I had to do it manually. I can see the total number of functions that are created by this JavaScript, and at the onload event, using Firebug, and the profiler in Firebug, I can get a list of all the functions that were actually executed. So I can just take a percentage of the number of functions executed by the onload before the onload event versus the total number of functions. Why do I do it at the onload event? Well, because the point of this analysis is if you have JavaScript that's necessary to render the page, you're drawing a nav bar at the top or populating, populating a pick list or something that's really critical to have that as part of the rendering of the page, you have to have that JavaScript in the page and have it delay the initial download, the initial rendering of that page. But if you have JavaScript that's like, if the user clicks on a button, you're going to pop up a div and let them type in a comment, you really don't need that until after the page has rendered, after the main part of what the user is looking at has rendered. And so what we can do is we can look at the functionality that's not used in the initial rendering, and we can lazy load that. And I'll talk about lazy load in a minute. So here we see, for example, AOL downloads 115K. Only 30% of the functions are executed by the time the onload event happens. Facebook, with a meg, only 9% is used. So the average is, across these 10 sites, about 250K of JavaScript is downloaded, and only 26% on average is executed by the onload event. So this best practice of splitting your JavaScript code and lazy loading the part that you don't need for the initial rendering is something that could really benefit these sites. So you have to figure out what's the part I need for rendering, what's the part I need afterwards. Sometimes that's clear. Sometimes it's difficult. There might be like a utility function that you might need if an error occurs in the first part. So really you have to pull that in. The hard part is, like I did this analysis manually, there aren't any systems that I know of that are publicly available to help with this, to help you look at what code is called as part of the initial rendering and separate the JavaScript automatically. There's a system, if you search for Delodo, there's a system from Microsoft Research where they've done this automatically, but it's a research project. It's not available publicly. So now, suppose you did have this other part of JavaScript that you wanted to lazy load that wasn't part of the initial rendering of the page. What would be really cool would be if you could download that in parallel with other things you were lazy loading, or even is there a way to download these scripts for the main part of the page without having this blocking behavior of scripts. So previously I didn't show MSN because they're doing something very cool. So after the HTML document, they have 3 scripts. So this is something you won't see across any other site that I know of. The 3 scripts are being downloaded in parallel. How do they do that? Well, one, it's Microsoft, so they know how browsers work really well. And this is what they've done in the page. If you look at the source code, I've done in orange the most important lines. They dynamically create a script DOM element and set some stuff there, and finally they set the source, the dot source of that script element. And when you do it this way in Internet Explorer, it will actually get all the scripts to download in parallel. Now this you can't just run off and do this. Like if there were code dependencies, if the second script actually called a function defined in the first script, you can't download them in parallel. Or at least you can't execute them in parallel. You could download them in parallel. So what I want to do, this is the hard part of the talk. This is a long part and it's very complicated. These are 6 techniques for downloading scripts in parallel without blocking behavior. So I'm going to walk through these really quickly, and at the end, try to show who the winner is. XHR eval. Let me download my JavaScript file, not with script source, but let me create an XML HTTP request and download it that way. And when I get the results, I'll just eval it, right? So this works really well. The one limitation is the script that you want to download has to be on the same domain. XHR only works that way. And you have to change your .js file a little bit. Instead of just all the functions and structured programming layout that you have to make it all one string that can be evaled. XHR injection is a similar technique, except instead of doing eval has some drawbacks, performance and security. What I do is I do the XHR, I get the response, and I create a script element, and I set that script element's text to the actual JavaScript that I have. And again, I don't have to refactor my script, but I have to have my script on the same domain as the main page. I could put an iframe in my page, and the iframe source is going to be an HTML document that just has a script block in it. So that works pretty well, but again, the iframe has to be on the same domain. I have to refactor my script a little bit. Now, instead of a .js file, it has to be a script block in an HTML document. I also have to massage my code a little bit because I'm probably going to want to do operations from the JavaScript and the iframe to the parent. So I have to have this parent and window.frames calling between the JavaScript and the main page. We could do like Microsoft has done. I call this script DOM element, create a script element dynamically, and then set the source. So this is great. You don't have to worry about the scripts being on the same domain. And you don't have to change your .js. You could deploy this, use this technique now, just like Microsoft has. You could add the defer attribute to your script tag. So this is only supported in IE, but it's really simple, right? All the other stuff involves some code changes or massaging. This is just 6 characters that you have to add to your page, so it's very lightweight. IE is a predominant browser probably for most of our user population, so it's going to have an impact. You don't have to worry. You know, it works with your JS files just the way they are now. Document.write only has parallelization in IE, and it will only allow scripts to be downloaded in parallel with each other, not with other things in the page. And all your document.writes for scripts have to be in the same script block. So what I want to do, let me go back to Kazillion, and I want to see if I can, there we go. I want to see if I can demonstrate these really quick. So here I've got a script and maybe an image. There we go. And I can say create. There we go. So they don't get the script blocks, right? That's the behavior that it has. But now if I change this, and let's do it as a script DOM element. This is what Microsoft does. So if you look at the source code here, here's the code to add the script. So I create a script element, I set its source, and I append it to the head. If we look at the packet sniffer now, we get a parallel download, whereas this one took 2 seconds, the previous one took 4 seconds. So you can use Kazillion and actually poke at all of these different techniques, XHR eval, XHR injection. You can see how they get this parallel behavior in Firefox, IE, and most other browsers. Something I haven't seen people talk about with these techniques, so Microsoft has this technique. There are actually other properties that do this. The Yahoo homepage will lazy load a style sheet and JavaScript at the end. But one thing I haven't seen people talk about that is important to me is how these different techniques affect the browser busy indicators. So there's more than 4, but there's 4 that mainly that I talk about. There's the status bar where it shows what it's downloading. There's the progress bar. There's the logo that spins, and there's the cursor that will show an hourglass. And so it turns out that which technique you use affects the browser busy indicators in different ways. So let's look at that. Turns out the XHR techniques don't trigger any of the browser busy indicators at all. I don't know about you, but I find it really annoying, especially when I'm using an Ajax application, and the progress bar and the status bar always show that something is happening. It makes me feel like the page isn't done and I need to wait a little bit. And if I wait 5 seconds and it still shows that, I go, oh, well, they're doing something in the background and I should ignore it and start engaging with the page. We see script DOM element for IE doesn't trigger any of the busy indicators, but Firefox it does. So it's not necessarily bad to trigger these busy indicators. If you're doing something like in Google Mail or Yahoo Mail, like drawing the inbox, that is something that's critical to for the user to engage with the page. So if you're doing that dynamically with Ajax and dynamically creating scripts, you would actually want to use a technique that did trigger the busy indicators. You want to let the user know, you want to give them feedback that you're still building the page and it'll be there as quick as it can. But then if you're doing some stuff like we've talked about lazy loading, if you're doing stuff where it really is in the background, this isn't necessary until the user starts interacting with the page or maybe for the next page, then it'd be good to use a technique where it doesn't trigger the browser busy indicators. Another issue is, do you need to ensure that the scripts are executed in order? I touched on that just briefly. You might have 3 scripts, and what if the second one actually calls a function in the first one? If you download them in parallel, willy-nilly, and the first one comes back first and it calls that function, you're going to get an undefined symbol error. So it turns out that there are some techniques that you can use. The script DOM element technique is one, where it will ensure, even if it will download the scripts in order, but it will download the scripts in parallel, but it will execute them in order. So let me actually show you one of these. So here I've got 3 scripts. The first one takes 3 seconds. The second one takes 2 seconds. The third one takes 1 second. But I've used the technique here of creating a script DOM element or JavaScript DOM element. So the one that's going to come back first is the 1 second one, right? But I actually want them to be executed in this order because maybe there are code dependencies. By using this technique, I can actually see that it executed the slowest one first because that's the order I put them in, and I used this technique, the DOM element technique. If I had done XHR, it would have actually executed the first one that came back first. And so if you had code dependencies, you'd get these undefined symbol errors. So that's another variable to take into consideration when you're deciding which of these techniques to use. So that was pretty good. Everyone's still here. So I'm kind of wrapping up now this second rule of try to load your scripts without blocking. So here's a summary of all these techniques. I also put the normal script source up there so you can see why we're trying to improve this, and how they affect IE and Firefox. And what I've done is I've reduced that previous table about browser busy into one column here. So what we can see is there's different techniques that affect IE and Firefox in different ways or have no effect. And I did an approximation about how many characters you'd have to add to your page to actually implement these techniques. So with that, we can figure out, what's the takeaway here? Who's the winner? Okay, so it's not that easy. This actually took a lot of work to come up with this. And it would be pretty easy to codify this. It's something I've started. You could codify it on the front end. It'd actually be more valuable to wrap this into PHP and Python to do it in the back end. So what you could have is you could have a back end web developer saying, oh, well, I've got these scripts that I need to load, and I do or don't depend on, they do have to be loaded in order, and I don't want the busy indicators to show because this is a background thing, or I do want them to show. So there's only 3 or 4 input parameters. You could just look at the URL of the script and know if it was same domain or not, because that really has a big effect on which techniques you can use. So there's not one that works. It really depends on the situation that you're in. But the good thing is I've distilled that into a few parameters. Is it the same domain? Do you want the browser to look busy or not? Do you care about the order? So if you can plug those things in, you can figure out which technique is going to work best for you. If you get this parallelized behavior, then it's really going to improve the load time of your pages. So try to see if there's a way that you can load your scripts without blocking other scripts and other resources in the page. Using these techniques that I've outlined, you can still control when does the onload event fire, are the browser busy indicators triggered or not. So all of this has been about external scripts. What about inline scripts? So this is the third of the 3 rules I'm going to talk about, so we're almost there. So inline scripts block 2. They block downloads and they block rendering. So here's an example. Let's look at this. So look, the page isn't rendering at all. The HTML document has already come down, and at the top, there's static text. There's the word gazillion up here, and this great tagline because there are a zillion pages to check, and these links over here. All of that's been downloaded before the inline script started executing, but the browser still didn't draw it. And that's because the inline script, once it starts executing, is not relinquishing control back to the browser to actually do paint events in the page. So you have to be careful of this. Again, we're adding more and more JavaScript to our pages, and we're getting these script loops in our either external or inline scripts that are taking a long time. The problem is inline scripts start sooner before the page has a chance to paint, and so they can block any rendering on the page. And we really want to promote progressive rendering. We want to give users feedback that the page is working. We still have some other stuff that we have to render, but the page is working, and they could maybe even start engaging. They could start reading the paragraph I have here or something on the page if we can get that to render more quickly. So there's a couple workarounds. You could, so suppose I have this inline script that has got some loop that it has to do, traversing the DOM or adding elements or something. Well, I could just call that through a init function, and I could launch that init function through set timeout. Now, a little tricky thing here is Firefox has this initialized paint delay value of 250 milliseconds. If your inline script starts before that, it's still going to block any painting in the page. So if you have a really burdensome inline script that's high up in the page, you actually might want to do a set timeout of 250. Otherwise, you could do a set timeout of 0. So that's one approach. Another thing you could do is take that inline script and move it to an external script and load it in one of the parallel non-blocking techniques that I just showed in Rule 2. Or you could use the defer attribute. It only works in IE, but it does avoid this blocking behavior that inline scripts have. Okay, so this is the worst part about inline scripts. It kind of makes sense that style sheets have to be loaded in order, right? If you have some cascading rules across style sheets, you want to make sure that the precedence is done in a deterministic way. So Firefox handles that by blocking when it downloads style sheets, just like it does with scripts. So that's not a great behavior, but it ensures that all of their rules are going to be evaluated in order. IE doesn't block when it downloads style sheets, but it still has to preserve style sheet parsing order, and there could be a connection between style sheet rules and JavaScript. A lot of us probably have written JavaScript that iterates over DOM elements and looks at those DOM element style attributes or even their class names. So if we did that JavaScript before the style sheet had been parsed and applied, we might get, again, a race condition and non-deterministic behavior. So all browsers want to try to preserve the order that style sheets are parsed and their relation with JavaScript. So what happens is, if you have a style sheet followed by an inline, if you have a style sheet and an image in IE, they'll be downloaded in parallel. If you put an inline script between them, it will be offset like this. So let's do that in Gazillion. So we'll get an external style sheet and an image. They both take 2 seconds. Oh, I'm in IE. I'm in Firefox. I got fire up IE. Okay. That's the other thing I love about Gazillion is you can just take the URL and email it to people and share it. Okay. So we get both of those to download in parallel. Overall, the page takes 2 seconds to load because each of those elements was configured to take 2 seconds. Now, let's put this inline script in between. The inline script doesn't have any execute time, right? I could, but I have it set right now. It's just going to have a simple variable declaration or something like that. And when I create this, the page is going to take 4 seconds to load. And that's because that inline script after the style sheet caused it to block. So now the image doesn't get downloaded in parallel. Why did it do that? Well, the browser said, I can't execute this JavaScript, this inline script block, until the style sheet is parsed. And I can't download anything after the script block until it's executed. So the image has to wait for the script block, and the script block has to wait for the style sheet. So now we get this sequential behavior again, which is not what we want. We want to try to promote parallelization of our downloading. So the kind of takeaway here is to not have inline scripts between a style sheet and any other external resources. So what can you do? You can move the inline scripts lower, but if you accidentally move them below, say, another inline script that depended on them, you might get a race condition or a code dependency error, an undefined symbol. So my recommendation is move your inline scripts above style sheets. But whatever you do, don't put inline scripts between style sheets and other resources in the page. And also, don't use the add import tag rule for loading your style sheets. Use the link tag. So I talked about this a little bit last year. Add import actually causes style sheets to load later, which is going to inhibit progressive rendering. And it also turns out that when you do add import, it's kind of like the browser is executing JavaScript. And so it says, oh, well, I can't do that add import download until the inline script is executed. So 2 style sheets that could have been downloaded in parallel will get staggered again. So don't use add import. Oh, okay, so I love this, looking at the top 10 sites. Okay, so guess what? So I look at this HTTP profile. So, and this is IE, right? So style sheets don't block. So sure enough, the first 2 style sheets come down in parallel. That makes sense. Now I've got this JavaScript file, and it's blocked. It's not being loaded in parallel. Why? One possible explanation, maybe it's on the same domain name as the first 2, because if it's HTTP 1.1, you can only download 2 things in parallel per server, per host name. But it's not. I looked at it, it's not. Why is it offset? Why isn't that JavaScript file loaded in parallel with the style sheets? So I look at the source code. There's an inline script block after the style sheet, before the script. If that inline script had been moved above the 2 style sheets, you would have had greater parallelization there. Those style sheets took about 160 milliseconds to load. So that one change of moving the inline script up would have cut 160 milliseconds off this page. MSN, we see the parallel scripts. That's really awesome. But down here, after the style sheet, between the style sheet and image, they have an inline script. So an image could have started downloading earlier. We want to get images down as quick as possible because there's probably content in the page that the user is really waiting to engage with. But here it's being inhibited by this inline script. Same thing with MySpace. That's a huge block because this one style sheet took a long time to come down. And here it is in Wikipedia. This one's kind of interesting because we see the last 2 style sheets here. There's 4 style sheets. So we got 3 of them loading in parallel, but the 4th one was done using @import. That's what I was talking about. And so it actually gets staggered. So it makes for this flatter HTTP profile, which takes more time. So don't scatter your inline scripts. They still carry a cost. They block rendering. They can block downloads. There are techniques, if you know you have inline scripts that take a long time to execute, there are techniques to avoid the blocking behavior that they can have, and especially pay attention to where you put inline scripts in relation to style sheets. Okay, cool. So let me wrap up. I always try to give people a few takeaways. The number one thing that I've been evangelizing for a couple years is it's great to focus on back-end performance. Most of the win there is not going to be in terms of user experience, user response time. You're going to get wins with hardware costs, bandwidth costs, power consumption, but your back-end optimizations are not going to really have a big impact on the user experience. If you want to impact load times, you've got to focus on the front end. Run YSlow. It's a great start. There's new rules coming out, so we'll have to think about how to incorporate those into YSlow. But YSlow is a great place to start, and it'll give you a vocabulary that you can talk across your company and even across companies in terms of performance. This year's focus for me is going to be all about JavaScript. It has a penalty even in the primed cache situation. And so, and we're moving to more and more JavaScript in our pages. So focusing on performance improvements that affect JavaScript are going to be really critical for the next year or two. And here's 3 techniques, 3 things I've found that have a significant impact. Speed really does matter. It affects the user experience, and it does affect your bottom line. And using techniques like these, there are teams at over 200 companies that I've heard from that are incorporating these best practices and seeing significant improvements in the load time of their pages. So it really is in your control to make your pages even faster and really improve that user experience. So that's it. Thank you. So there's 2 mics here, and if you would come up and state your question, I can take questions for about 9 minutes. Hi.
Hi. This is totally the focus of my job right now, and what I have figured out, which everybody knows, is that IE sucks. I mean, IE is terrible. It's incredible. It's like 4 times slower than Safari, twice as slow as Firefox. So can you speak just to the point of IE, because it's still kind of the standard because it comes boxed with everything. So a lot of people are using it. I mean, my attitude is if people are using IE, they're obviously not interested in performance, so we shouldn't have to worry about them, but nobody agrees with me. But could you just talk about IE and how you optimize for IE specifically?
So if I could summarize the question, I think it's why does IE suck? I actually think the IE team is doing some good things. JavaScript performance goes up and down. WebKit this week just had some good improvements in JavaScript performance, and it's really great to see Mozilla and WebKit and IE, really trying to establish themselves as the fastest JavaScript engine. And I hope that continues. That's just good for users. But I look at things like the fact that Firefox blocks on downloading style sheets. I look at things like IE8 moved to 6 parallel downloads per host name, and now I think Firefox 3 is following that. IE8 actually will download scripts in parallel, but execute them in order for you automatically. So a lot of those techniques I talked about in Rule 2 really aren't going to be necessary for IE8. Now, that doesn't help us out for about 3 or 4 years, but it's a step in the right direction. So I definitely think that there are things that IE isn't performing well on, but I think there are other things where they're kind of leading the way. And there are a lot of, IE really tries to blaze the trail with, other things, filters and stuff like that. And I think that's where they run into a lot of problems. So I think if you stay with features that are supported across all browsers, I would actually question whether you would see from an end user response time perspective, IE performing more slowly, and I would actually, give 2-to-1 odds it might be faster. And that would be a fun study to do. If you want to come up afterwards, we'll figure out a way to set that up. Vic from Keynote sitting right behind you. He'll let us set it up on Keynote, and we'll gather some data. Yeah. Oh, I just wanted to mention that. I already did. There will be guys from the IE team and Firefox team at Velocity, and they're going to do talks on how to program in their browsers, how to build your pages to be as fast as possible for their browsers. And so it'll be a good opportunity to bring up issues and hear some best practices they have to say. I'm sorry.
Sorry. Is this going to be available online?
Yeah, it'll be on my website in about 15 minutes.
All right,
SteveSouders.com. And probably on Google I/O. I don't know. Hi.
Hi. A lot of what you're talking about reminds me scarily of the optimizing compiler discussions we were having like 20 years ago. So why are we working on analysis and how to work around the problems instead of a tool chain that fixes it so people don't have to worry about it?
You know, that's to me, it's a simple answer. It's that, it's great working on web apps because you can push a change and instantaneously everyone is updated. But that's not true with browsers. And we've got IE6. How long has it been? 3 years, and it's still the predominant browser. And so we have to deal with this, even though IE8 has all this great stuff, and Firefox 3 as well. Has new stuff that they're doing. It's going to take years before IE6 and IE7 are going to fall off the charts. And so until that happens, we can either say, well, I'm going to program to the future because I know the new browsers are doing cool stuff and they're doing it the right way, or we can say, for our users' sake, we're going to have to figure out how to kind of circumvent some of the shortcomings of the most popular browsers that are out there. Hi. Oh, you'll go next. Okay, go ahead.
Yeah, I kind of have to disagree with you. The big problem with IE isn't so much that it may run JavaScript better or worse. It's the memory issue on it. If you're going to build persistent apps that use it as a de facto OS, the preemptive memory issue, and Joel Weber's done a really good job showing this, and IE guys are kind of like working on it, and they thought they fixed it. But the problem is they're still thinking like desktop. And I have to also kind of go take a contrarian view about we just have to still deal with it and spend 60% of your time fixing their problems. No, what you do is you build compelling apps that have real value, and then you tell your users, if you want to get the real value of this app, use this browser. And that's our responsibility. We're the tool makers. If you make compelling enough apps and say, we're not using that crap, and I'm not going to fix their problems, our users will migrate. And that's what happens with every wave of technology. And that's our responsibility as quality app makers. So I just have to slightly disagree. I think that's the approach, and that's what's going to happen with mobile coming into. That's why WebKit and some of the other browsers that are built for mobile and other experiences will, in fact, drive users in that space. Because there's a big pot of users up for grabs.
Your emotion advocating for your users is awesome. And that's really all of our responsibility, right?
It's a business decision. I actually build startups, and we advise News Corp, the big guys who are dealing in mobile in this space with hundreds of billions of dollars a year. We just made $100 billion in SMS revenue last year. So it's not emotion, it's the reality of the new markets. I don't deal in emotion, I deal in money.
So I'm not that. So I think the main disagreement was centered around IE's performance issues with memory management, and I'm not that familiar with those issues. So we could talk more after. But I do agree. I think you brought up a really good point of trying to more aggressively encouraging users to upgrade. I think that's a great idea. Yeah.
Hi. Can you talk a little bit about performance of regular expressions in JavaScript, optimizing it, and maybe suggest some references?
No, what I try to focus on are the things that I see that across most websites is a significant problem. I try not to get people working on things that really aren't going to have that much of an impact. So I certainly believe it's possible to create regular expressions that could have a significant impact on performance. I'm just not seeing that a lot at Google and at the other websites outside of Google that I look at. So I haven't dug into that very much. So I don't have an answer about regular expressions.
Hi. How much HTML design effect, like table versus div float and the error in the CSS, like if you not using proper standard in CSS, does it affect the performance of the site?
Does what affect performance?
The error in the CSS, like you are not using proper expression in the CSS, some incorrect tag or some incorrect spelling there, the semicolon is left.
CSS errors? I have not seen any instances of that. The one thing I have talked about is the use of CSS expressions. I've actually seen CSS expressions make a site 20 to 30 seconds slower to load. But I haven't seen other kinds of CSS errors have an effect. Hi. And then after this, we'll do 2 more, and then we'll call it quits.
Yeah, yesterday in this room, they talked about JavaScript frameworks, and they basically said, choose the one you like. How would you choose the one, we're talking jQuery and Dojo, et cetera. Have you seen one that is a really good one to choose when you're also trying to couple it with these optimizations?
I haven't done a deep dive into that. I think one thing that's important, yesterday, I think it was yesterday or the day before, Google announced the Google Ajax Libraries API, which basically Google is now hosting 5 of the popular frameworks. And they're going to add more to that and more versions. But basically what that means is that you can get it off a Google server, which probably is going to be very close to your user, no matter where that user is worldwide. And their headers are going to be set up correctly so that it will be cached and gzipped. And if the framework provider has a minimized version, that will be available too. So on my blog yesterday, I did do a size comparison of the frameworks, and there is quite a difference in the sizes. And so that could affect load time. But especially if you're downloading it off Google, I don't think that the download time is going to be that critical. And so I would make that choice about framework based on features and coding style. Yes?
Can you throw some light on security while using the XHR eval technique?
Security?
I mean, some untrusted scripts can be inserted if we are just performing eval.
I think the question was, can I talk about security issues with scripts?
Particularly using the XHR eval technique.
Oh, eval. Well, if you're 100% confident you know what is in that eval string, it could be okay. What I would worry about is giving rope for people to hang themselves where you evangelize this technique, and maybe people start doing it with ads. And guess what? Ads are coming from third parties that you don't have a lot of control over. So you just want to be, with eval, you want to be especially careful about how you, what JavaScript you're serving through that technique. Last question. Hi.
Hi. One of the points that you make with YSlow is that reducing HTTP requests is rule number 1, and parallelization is good if it's possible. But what are your thoughts on the server end combining some of the JavaScript files, and then of course maybe running something like YUI compressor, minifying it, and serving multiple scripts together? Do you see that happening much on sites in order to reduce HTTP requests and maybe provide better performance than even parallelization?
Yeah, if you look at more and more people are doing that. If you look at Yahoo, they're doing that, combining scripts together. And all these things kind of go hand in hand. It depends on how much you want to bite off. If you aren't going to do any of the advanced techniques or splitting stuff, then I would argue try to make it one. Combine it all into one request. But you could actually, the best thing to do would be to split your JavaScript. The stuff that needs to be downloaded for the initial rendering, put that into one external file and download that as quick as you can. And then the other stuff download asynchronously without blocking. So yeah, combining files is a good technique. Still a good technique. Okay. I'll stay for any other questions. Thank you very much.